Hello, this is a tutorial for t-test. The first we're going to do to demonstrate to you is how to do independent sample t-test. So independent sample t-test is best when you want to know whether subjects in one condition is different from subjects in other conditions. And we call this also between subjects design. So it's the opposite of the situation where the same subject participated in experiment 2 times. That's called a paired sample. So we want to see if subjects in one condition is different from other subjects in other conditions. And again, you use this t-test because your IV is categorical and your dependent variable is continuous. We're going to use this survey data called digital literacy skills final, right? And which we're going to follow this procedure. We're going to run the results, which I have already loaded up my data. You can find this data set in the canvas that I provided to you. So you can see we have these variables. It's the same set of data set that we had last time, and you need to check your variable view. You make sure that your data is properly coded into a scale or nominal or ordinal, etc. So in this, we want to show you how to do compare means using the independent sample test, which your IV is gender. You group them in terms of 0 female, 1 male. So you have to be very careful if you use it 0 female, 1 male, or you have to be consistent and make sure that you get the right coding and you continue. So it's the variable is gender and the outcome is the digital skills. So go to analyze, compare means in a sample t-test. Where is my, oops, it's already here. Let me just reset. So the exam score, this is digital skills. Again, digital skills is my dependent variable. So digital skills, and gender is my grouping or my independent variable or grouping variable, right? So I have nothing to do here for options and bootstrap. I need to define the groups. So you have to be very careful to see how you coded the data. So if you look at how you coded the data here, in terms of gender, male first at 0 and male second, right? So female first and then male second. So 0 and then 1. So when I go for analyze, compare means independent sample t-test, my gender, this is 0, this is female, this 1 is male. They like to ask us to specify which one is group 1 and group 2. That's pretty much it. You can just click OK. So this is what the result that we get, which is exactly the same as this one, right? It shows that the mean difference, there's a mean difference 61 and 62. The mean difference between male and female is not very different. Actually, you can see just the mean value is not very big, 61.2 and 62.9. And the variation is very small. But how do we confirm if this is significant? We need to go to the independent sample t-test, look at the Levene's test. So again, I mentioned for the Levene's test of equality variance, we want it to be not significant. When it's not significant, then we can use the one at the top column. So we assume that equal variance is assumed, and we can report with this t-value, this degrees of freedom, and this p-value, right? So we can conclude that from the survey among the elderly participants of digital skills, and we collected 20 participants, the digital skill score for female is 61.2, this one, for female. And for not very different from male, which is 60.9, at T23 at minus 0.52, and P is not significant, which does not support the hypothesis that gender influences digital skill score. That's how it is to do the analysis by clicking the buttons and interpreting the results. The second one that I want to show you is how to do repeated measures, t-test. Repeated methods is you use it because you're testing the same person 2 times, or we call it within subject or post-test, pre-test, post-test design. So I've created a data file here. The hypothesis is digital training improved the digital skills of the elderly participants. So I want to see the pre-test and post-test score of the digital skills, right? So let's open the digital literacy skills pre and post. I have already loaded up on my computer. Yep, so this file is a little bit different from the previous one that I've just opened because there's additional 2 variables here. The pre-test score. So this score, this is post-test, or the default data is post-test after the elderly participate in this program, in this digital training program, right? But I added a data on pre-test and also specify who among them joined 0, 1, or 2. What is 0, 1, or 2 there? Look at that digital training program. Oh, 0 means online. This is how I coded it. 0 means online learning. 1 is face-to-face. 2 is hybrid of online and face-to-face. So that allowed me to understand from online to physical to hybrid, right? So what we need to do is just follow this procedure to do the paired sample t-test. So this is what we exactly want to do. And our variable is exam score, post, and pre. So you have to be very careful in terms of which one that you are entering as a post and as a pre. So I'm going to go to analyze, compare means, pair sample t-test. So what I do here is I will put the pre-test here as a first one and the post-test here as a second variable. So I'm comparing the pre versus the post-test to see whether the pre and post-test are very different or not. When I calculate it, when I click the output, it will give me the results. And these results is exactly the same as the one that I put it up here. So the exam score before is 40 and after is 62. Here, before is 40 and after is 62. It's the same. And there's a correlation 0.4 at 0.018, and it's significant. So it's significant at t minus 7.097. So we can write a conclusion that we concluded the intervention among the 24 elderly participants to know if the intervention improved digital literacy skills. The mean score for digital skills after joining was significantly different and higher than the mean score before joining the program. So the T can be positive or negative. It depends on which one that you put first in when you input this variable. Let me show you quickly. It really depends on where you put as which one is. Here I put this is the variable known as the pre-test, variable 2 is post-test. But if you reverse it, the result will be totally different. Because I put the pre and the post, the result is the t-test is negative. But if I show you the post as the first one and as a variable 1 and the pre-test here as the variable 2, the result is going to be the other way around. So the t-test is 7.09 is positive rather than negative. It doesn't really matter. It just say there's a difference, and this difference is significant. Hopefully that's useful for you. Thank you. Bye.